So when we do simple trinomial factoring, and then yesterday we also did common factoring and difference of squares, and those are the three straightforward ones. Tomorrow we're going to put all of them together, and I'm going to come back and talk about why common factoring sometimes is a bit of an issue. And in fact, if you look back at that first test that we did for the sort of preview unit, some people missed that question on the test. And on its own, common factoring is pretty straightforward, and you probably find it easy, but mixed up with the rest of them for whatever reason, it becomes tricky. Okay, so just something to think about, but we'll talk more about that tomorrow. But those are the three easier kinds. Then we do complex trinomial factoring, and if you look at example 1a, it looks a lot like a simple trinomial with one slight difference, but turns out that difference makes the procedure very different, right? So it's not just a small step up, it's significantly more challenging, requires more careful steps and a very different procedure from simple trinomials. That's just two numbers that add to this and multiply to that. Okay, so this is definitely an algorithm that you need to learn, memorize, practice so you get good at it. And different from the other ones that we've done so far. Like I said, today we're just focusing on this. We have seen it before, but we're revisiting it because it's been a few weeks, and it's good to look at things again a second time around. Then we're going to put them all together tomorrow, and there's going to be some sort of like new ideas and new learning and new things to notice when we do that. And then we move on to other things and start using the factoring to do other things. Okay. So we talked about this before. How do we get there in the first place? This is going to highlight at least a little bit why complex trinomials are harder. I do 3 times, whoops, not that. Whoa, I went too far. 3 times 2x and 3x times 3. Then 1 times 2x and 1 times 3. So similar to simple trinomials, yes, you still get 2 middle terms that add together. Why is this harder? TK, what do you think?
Because there's nothing in front of us.
Yeah, the number in front of the x is what makes it a complex trinomial, right? And expanding is going this way, and factoring is going that way. So factoring is going to turn it back into the brackets. The difference is it's not just 2 numbers that add to 11 and multiply to 3, because the numbers that multiply to 6 are a factor in all of it as well. The 11 came from 3 times 3 and 1 times 2. So it matters what that number is and what that number is. And in this case, they could be 3 and 2 or 1 and 6. And we don't know if the 2 is going to be in the brackets with the 3 or if the 2 is going to be in brackets with the 1. Like, we can't tell. So it makes it quite a bit more challenging. So you've got this written down. You've had it written down from the handout at the beginning of the course as well. But if you weren't here, then now you have it. So we have a very specific way. And you have, like, it's specific. If you do things out of order, it won't work. This procedure will not work. List the factors of the coefficients of the first and last term. So we're talking about those. And we're going to list them in a specific way. And then we're going to put a line between them, right? And then cross multiply. So pick a pair on one side and a pair on another side. Multiply the top by the bottom and then the bottom by the top. You're going to add them or subtract them depending on what the signs are like. And then we have to know how to read our answer. When we find the pairs, we read it across the page and put them into brackets, because we are going to have an answer that looks like that. 2 sets of brackets, 2 binomials. All right, let's try the first one. So we're going to start with a couple of easy ones that don't have any negatives, and then we'll add negatives because that does change things as well. So I take the coefficients of the first and last term, 1 and 3, draw a line, 1 and 2. And what do I have to do as well? before we move on. It's not really written in the instructions, but who remembers what you have to do? Flip one of the sides, either all of the pairs on the left or all the pairs on the right. You don't have to do both. You could do both. It wouldn't be wrong. It would just be extra work. So I'm going to flip that one. If there were 6 pairs on one side and 2 pairs on the other side, you'd flip the one that has fewer pairs. I know the answer is going to look like this, but I don't know what to put in the brackets yet. So I do 1 times 2 and 3 times 1. And we'll talk about whether you're adding or subtracting when we get to those different ones. For now, we're just adding. So that's 3. Sorry, that's 2 plus 3,
5.
which is 5, which is your middle term, so we found them. What if I did the other 2 first for whatever reason? 1 times 1, 3 times 2. 3 times 2 is 6. 1 times 1 is 1. 6 plus 1 is 7. Not the middle term, so not the correct pairs. So we'll go back to the other 2. So we got 3 and 2, and 3 plus 2 is 5. So that's the one that we want. Then we read our answer across the page. Remember, sometimes I circle the pairs and then read our answer across the page. So that's 1x and 1, and 3x and 2. And in this case, everything's positive, so we're just adding both of them. I don't mark this work if you are doing a test and there's a bunch of them and you kind of get all of them wrong, but you're showing me that you have some of the algorithm correct, like you understand that, you write them out. I'll try to give you some part marks or something like that somewhere, right? But generally speaking, I'm not worried about the form of this. I'm worried about your final answer being correct, with the correct numbers and the correct signs. So, but unless your mental math is awesome and you get really good at this, if you write this part wrong, you're probably not going to get the answer right. So you do have to kind of know how to write it, but there are other slightly different ways that some other teachers sort of show their work or write their work. You can solve these without doing that when you have done enough of them. There are a couple other methods of doing complex trinomials. So, that's what I'm saying. You don't necessarily have to show that for marks, but you got to know how to do these. Okay. So try the next one. At least try to write out the pairs. Okay, so it should look like that. I flipped the 1 and the 2 because there's fewer. And then you got 1 and 10 and 2 and 5. So 10 has 2 pairs of things that multiply to it. I like having an order of doing things because I've said this before. It actually does make it easier for you if you develop habits. So notice that I always kind of start with 1 and then I count from there. 1, 2, 3, 4, whichever ones work. So you're not kind of just randomly picking the pairs, because then you might miss one. So it's not a bad idea to do them in some kind of order, whether it's smallest to biggest or biggest to smallest. So how do we do this? So we do 1 times 10, which is 10. Don't write all this down. Just watch for now, right? Because if you write this down, you're going to muck up your stuff. I can erase it. 2 times 1 is 2. 10 plus 2 is not 9. 10 minus 2 is not 9. So that's not the right, those are not the right pairs. These two together are not the right pairs. 2 times 10 is 20. Well, that one's not going to work. It's way too far away from 9. You're not going to be getting back to 9 from that. So what's the correct pairs? 1 and 5, 2 and 2, is 4. 1 times 5 is 5. We're multiplying now. 4 plus 5 is 9. So that's the right one. This pair and that pair. Read your answer across. Don't forget your equal sign. So that's 1x plus 2 and 2x plus 5. Oh, not x, y. Remember we talked about this before too. Isn't that funny? That habit of always using x. So just watch. Just watch. Y times 2y is 2y squared. 2 times 5 is 10. 5y and 4y is 9y. Check your answer. Why not? And if you remember back to the learning goals and the quiz that we did on this before, and people who got wrong answers, and if you do the check, you look at it and go, oh yeah, it's definitely wrong. Sometimes people end up with weird things, and they might end up with something like, well, wait a minute, 2y times 2y is not 2y squared. It's 4y squared. You know right away that it's wrong. Something's wrong here. Okay, so it's really useful when you can check your answer to take the time to do it. Yeah?
So my answer is the same, but my bracket flipped.
Yeah, that's totally fine. It does, order of brackets doesn't matter. You could write it that way too, for sure. Okay, try this one on your own. Did you get x plus 2 and 2x plus 3? So again, I can check. 1 times 2 is 2. 2 times 3 is 6. And I've got 3x and 4x. 4 plus 3 gives me the 7. So we got that one. Any questions? Good? Okay, next one's a bit different. Why? Because there's negatives. The start is the same. Twelve has a lot of factors, so I'm going to flip these ones. You could common factor both of those, but not the middle term, so it doesn't help because it's got to come out of each of the terms in order to be helpful when we're doing this kind of thing. So it's good to look for. I don't think any of these have a common factor. We're just going to focus on the complex trinomial part. But it's good to keep an eye out for that because that does come up. Everybody got those written down? So just watch for a minute. When we go back up here, whoop, and we look at all of this, why did we get a positive result when we multiplied to get 3? Because both of the numbers that multiply to it were positive. What else multiplies to a positive, though?
Negative and negative.
2 negatives. So they would have to be the same sign to give us a positive there. So if we have two numbers that are multiplying to a negative, because they multiply to negative 12, what do I know about them? One's positive and one's negative. They're not the same. They're not both positive. They're not both negative. The only way to multiply to a negative is if one of them is an only. Okay, so that means one of them's positive, one of them's negative. When they add together, you're actually going to be subtracting. Like you're going to be finding the difference between the two. So as I'm doing my dance between the different sides here, I multiply, switch and multiply, and subtract those two numbers. So we're looking for a difference of negative 1. Okay? So let's see. 1 and 12, 6 and 1 doesn't have a difference of 1. You don't actually have to calculate them all if you just know it's wrong. 1 and 6 is 6. 6 times 2 is 12. Again, not a difference of 1. 1 and 4, 6 and 18. Nope. So we've got 2 times 4 is 8. 3 times 3 is 9. 9 minus 8 is 1, or 8 minus 9 is negative 1. Whether it's 1 or negative 1, we're going to do that at the end. But the point is, when you subtract them, you get the 1 that we're looking for. Now, I kind of went through that quickly. Okay, so I'm going to sort of go over it again. But you're starting with this one and trying each, and then move to the next one, trying each. But when you get experience at this, I kind of, when I got to the 2 and the 3, I skipped these two because I could already tell that that was going to be the right one. But that just comes from experience. The idea really is that you're systematically, one by one, going through each and trying every pair. Remember, this is what I said when we did this the first time around. The answer's there. Sometimes you start to panic a little bit and you think you've done something wrong because you can't find it, but no, the answer is absolutely there. Okay? So you just have to go through them one by one carefully. Make sure you're adding or subtracting as appropriate, and you will find the answer. So it's 2b and 3, and 3b and 4. And do I want 9 minus 8 or 8 minus 9? I want 8 minus 9. So if this is giving me the 9 and this is giving me the 8, I want that one to be negative so that I get negative 9 plus 8, because 8 minus 9 is your negative 1. Everybody okay with that one? Again, you don't have to show this. You can if you want. It's there for the learning. It's maybe something you just do in your head. But if you really want to be careful, then you can also write that down. So this one, again, multiplies to a negative, but instead adds to a positive. So it turns out that's not really going to change what we do until the very end, just where the positive and negative go. But they multiply to a negative, so one of them is positive and one of them is negative. So write out the factors of 3 and 10. You can try that. So it should look something like that. Again, remember we talked about this yesterday. With factoring, you got to know what the answer looks like. You have to know that what this factors to two binomials. And then we got to recognize it as a complex trinomial and remember the procedure for doing that. What are the two pairs of numbers?
Yeah, 1 and 1, 12 and 5.
Yeah, so this 1 and 3, because we don't want that 1 and 3. We want this 1 and 3. So 1 times 5 gives me the 5. 3 times 2 gives me the 6. Does it make a difference? Yeah, it does, because that's gonna matter what goes together in each bracket. So that's why you have to multiply across, diagonally across the line. Okay? So in this case, 6 minus 5 is positive 1. So I got 1x and 2, 3x and 5. I want the 5 to be negative. Okay. Okay, I want you to try this one on your own. As best as you can. Take it step by step. If you can at least write out the pairs of numbers, then that's a good start. So that should be your list. Do you have a question?
No,
The answer? Okay, hold on. How many people have this one done? Okay, good. So I got those two. 2 times 2 is 4, 3 times 1 is 3. It's the difference because you're multiplying to a negative. 4 minus 3 is 1. Okay, see if you can write the answer. Or at least, like, the part of the answer, even if you can't do the signs. Remember, we talked about this. Like, sometimes you feel confused about the procedure as a whole, but you can do some of the steps, maybe even all the way up until the very last step where you're just confused about the signs. So chalk that up to like a positive. That's a win, that you're on the right track. You got one little step left. So it should look like that. Reading across, 2 and 1, 3 and 2. And I want the 4 to be positive. So it's 2 times 2 to give me the 4, minus the 3, so that 4 minus 3 is 1, as opposed to 3 minus 4, which is negative 1. What do you think? 2 more. These are the last type that we haven't quite seen, where we have a positive here and a negative here. We've seen every other combination. If two numbers multiply to a positive, then they have to be both negative in this case, or both positive. Why both negative? Because you're right, because of the negative in the middle. So in this case, it's both negative, absolutely. But we know they have the same sign. Okay? And that means we're adding. That means we're adding them up when we do our pairs. So 1 and 3, 3 and 1, 1 and 5, both prime, so they each only have one pair. Flip one or the other. This is the kind of thing where when I look at this, and again, this just comes from experience, but I'm looking at that and I'm like, 3 times 5 is 15. That's pretty close to 16, isn't it? Kind of gets you in the ballpark. Kind of makes me think that's probably the answer. So even though there's only a couple of options to try here anyway, that one jumps out at me. And the better you are at mental math and the more of these you practice, you eventually get to that point where you can kind of guess more quickly and be more efficient at which one it is. And you may not have to check every single pair. And turns out that's correct because the other one, 3 times 1 and 1 times 5, that's 8. So that doesn't work. 3 times 5 is 15. 1 times 1 is 1. 15 plus 1 is 16. So I'm not worried about the signs there. I'm just thinking about the fact that I'm adding them up. Because it's not part of my answer. That's my thinking. I'm adding them to get 16. Yes, it's negative 16, but we'll take care of that when we get here. So 3x and 1, and 1x and 5, and they have to both be negative. So I get negative 15 minus 1 is negative 16. Okay, last one. I want you to try it on your own. So there's the list of numbers. And again, you can check the steps along the way. Did you get all the numbers right, or were you missing a pair? And just keep that in mind for the future. If you're stuck on one, say to yourself, sometimes I miss a pair, so maybe I should go back and think that through. And again, there's one pair that jumps out at me here. Why 6 times 5? Yeah, well, it's 30. It's close to 32. Yeah, exactly. Yeah, very good. Right? It puts you in that ballpark. Doesn't mean it's the right answer. Because there are others here that might be the same. I mean, 12, well, 12 times 5, that's probably way too big. That's 60. But, 4 times 5 is 20. I mean, that's kind of getting close, but the 5 times 6 to me puts me really close, and then turns out 2 times 1, well, there you go, 30 and 2 is 32, so that's the pair we're looking for. Read your answer across the page, 2 and 5, 6 and 1, 2a minus 5, 6a minus 1, both negative because they add to a negative. But they multiply to a positive, so all of those pieces fit. Once in a while, there are questions, it's not designed on purpose, it's a fluke, where you can subtract to the middle number when you're supposed to be adding, but it kind of still works. So you fool yourself to thinking that it's right. So you really do have to think about the signs, both signs, the sign of the middle term and the last term, every single time, whether you're adding or subtracting. You can't necessarily just hope you get lucky. So I've seen people put an answer that kind of makes sense, except their signs are just don't work with the question. Otherwise, things would make sense. I hope you kind of understand what I mean. Okay. So that's that. So now there's lots of practice in the classroom to take a crack at, and tomorrow we will put all the different types together.